Today we're gonna do the last questions of the exam. بغاها؟ ايش يعني بغاها؟ بغاها ايه لا عشان ما دوبي سجلت عشان ابغى شعر. ها؟ بغبغان. ايش بغبغاء؟ هذا عندكم في جيزان. بغبغاء عندكم. أما مساكين والله الله
This is
يعينهم.
another formula that I
حياتهم
need to
صعبة.
give you the question last time. It's called histogram equalizations because we have two formulas. One is Peter Kadush, one is CZ. So before I will give you a Peter Kadush formula that I expect. CZ will mark you second part. I'll give you CZ instead. Because when I studied, I got different formula. Now this guy gives you another formula.
Yeah.
So I'm.
You know, question 7, there is a part we haven't done it. That's what you are talking about?
You already done question 7.
We've done it.
We done it. All question 7 already.
No, no. One of the questions. 7. You told you. No, no, question 7, please. Yeah, with this part.
We already done that. Erosions, and then we do histogram equalizations.
Yeah. What I mean, one of the question 7, one of the year, you.
Yep, because that is belong to question 8 now.
Yeah, we're gonna do it, sir.
Yes.
Yeah, alhamdulillah, yeah.
But I will do this quickly again using the same formula.
Okay.
So let's say if you want to do histogram equalizations. Now, first step you're going to do is original histogram, right?
Okay.
So to do original histogram, I recommend that you table like this. This is values. Pixel 0, pixel 1, pixel 2, 3, 4, 5, 6, and 7.
And then CDF.
PDF first.
Okay.
If you
Already CDF. Oh, okay. Doesn't mean that.
How many zeros in there?
3.
0. How many ones?
2.
How many 2?
1.
3.
1.
4.
1.
5.
0.
0.
6,
1. 0.
Alright. Then you can calculate the PDF in percentage.
Yeah.
So
0.33.
3/9 to make it easy.
وعليكم السلام ورحمة الله.
2/9, 1/9, 1/9, 1/9, 0/9.
خلاف عنده
1/9.
كبار عنده لاب.
Yes.
Okay.
Then we can calculate the CDF. CDF.
سؤال 7 حق 2000.
That would be
Question 7,
3/9.
2014,
This one will be?
part B. هذا
I'm not sure why we
حللنا
decided to go for
بطريقة أخرى.
9, there is already 9
Okay.
percent. Probability.
بعدين نبدأ
There
8.
is 9 and then 3 of them, 3/9.
Yeah.
CDF here will be?
5/9 or what?
1/9, this
Yeah.
one,
6/9,
this one.
7/9, 8/9, 8/9, 9/9. حلو. البي دي اف بالبرسنت اللي هي 0.33.
طيب
ما تتذكرها؟ ايوه. طيب بدل ما 0.
شوف بدأ فوق 3 على 5 على 9.
ايه خلاص حلو. 3 divided by 9 it will be 0.33 صح؟
Yeah.
اوكي.
خلاص روح معك افهمها بعدين نجلس عليها.
الانستغرام هذه حليناها.
ما راجعتها يعني.
Okay.
ما راجعتها. فيديوهات موجودة.
Okay. Keep going. Yeah. Now,
اول مرة اسويها.
in order to do equalization, you need to use this formula. You expect to remember.
So what طريقة
that is not.
We have to remember it.
Yes, because it's not given to you in a formula sheet, so you need to remember that one. So this is a formula to do.
هذا لازم نحفظها.
Equalizations. Now
هذه
in this
الفورمولا اللي
one you
تسوي
have
انستغرام
SK.
ايكولايزيشن.
SK, which is this one.
هذا ما حلينا الفورمولا شيء.
This one we call it SK. Yeah. So the VK here will be calculated using SK minus S
Minus
minimum.
S minimum.
So you look at here, which one is the minimum one? So obviously this
The
one.
first one.
So always the first one is the minimum, right? So minus 3 over 9 over 1 minus 3 over 9 multiply with L minus 1. L is the number of levels that we have. 8
7.
levels.
8.
Seven.
So multiply by 7. Yep, so this is a formula that you need to use to equalize that one. Then you calculate this,
لا، L.
this.
8. هي 8 يعني تطلع 7 يعني.
Okay, so you substitute here. It's SK, right? If you want to calculate it, you put here in here.
As it
Yeah.
So that should give 0
It's
to 0. And round of this one gives you 0. 0 round to 0.
Yeah.
Then the next one you substitute 5 over 9 over here.
5 over 9.
Yeah. So you have calculator.
I don't know.
I just can
ما
find
نشوف
it.
جيبوا على
Okay. I will use it by my phone. Yeah, I will do it.
لا تطلب احد انت ما عشان
ليه؟ Don't care. I will do it. Yeah.
جاء المستشفى على طول هنا.
وانا مترت الشارع اللي عند البيت من البيت للجامعة مرتين.
Okay. 5 over 9 minus 3 over 16. ما راح تطلع. It can't be like this one. لازم قلم طيب.
تفضل ايش في خالد.
ليه؟
Yeah.
Do we need this for the rest of the solution?
2.
or no?
Yeah.
It will become 2.
No, you expect a
So 0 point
next
something.
2 point something.
2 point something.
متفق على ما نزل.
يا كلب يا اخي.
انا فجعني ان خالد اليوم يقول ما نزلت من الحقيقة.
امس ما
When we get this number, we multiply it by 7, yeah?
Yeah.
على 0.55555 no, I guess 0.013.
That can be. Yeah. No, why?
So,
1 minus
Yeah, sure I am about it. Like.
ready?
Multiply by 7 equal 3.
Exactly 3?
Yeah.
No. I will try this. Let's see.
والله سوري لي
2 point something.
5 over 9 minus 3 over 9 divided by 1 minus 3 over 9 then multiplied by 7. Mm-hmm. 2.33.
Yeah, I told you. So it too.
Alright, so rounded will be 2.
2.
The next one will be
6. Just change the
2,
6.
6, 3.5, rounded will be 4. Next one, 7,
اللي فوق عليه مسوينا له راوند
4.7,
3.
5,
ها؟ بس تقول كم اعلى قيمة نروح نسوي لها راوند.
right, will be 5.8.
لا
القيمة القريبة منها. خلي.
5
إيه؟
حطها 4 3 حطها 2 7 حطها 5.
انتم قلتوا لي المره الماضيه 2.1
شوف الفيديو
ينقص 3.
شوف الفيديو
لا
لا تقولنا شيء ما قلناه.
5 وفوق ايوه. بعد البوينت 5 وفوق ينقص للرقم الجديد.
Okay.
تحت 4 وتحت.
فرشت الفيديوهات.
Alright, and then the result of this one.
قلت فيديو واحد بس مخلص انا كله.
انا ما
Okay, result of this one will be based on this mapping. The 0 will become 0. So 0 stay in there. The
Okay.
1 will become 2. 1 there, there.
2.3 2 sorry.
The 2 will become 4.
4 just 1
The 3 will become 5.
just 1.
The 4 will become 6.
سؤال طيب.
5 will become 6. 6 will become 7.
No 5 there.
So that is a result of this equalization. So you will need that in the exams.
ليه؟ So should we write the previous answer or this
This
answer?
one.
Erase it.
Mhm.
The previous one.
Yeah, this one is correct one based on the same.
Cool.
Alright, so this one is the first things.
بس ابغى اعرف
Thank you for that ليه.
كيف حط 3 على 9 2 على 9 من فين جابها؟
حلو. طيب 3 على 9 كم تساوي؟
عارف اللي هو
0.3 خلاص سوي عليها كذا.
لا من فين جابها بس ابغى مراجعه كذا.
ما جابها من مكان ما ورانا هي. هتشوف الفيديو ما
Alright, so
ورانا.
we have
بس
erosion
خلاص،
and
أنت عارف
dilations. We got before.
ما تدقر عليها اي. الحين من بداية السمستر ما دقرتوا على الرقم واحد في الدي اس بي ما شاء الله. يا تدقر على دي؟ ماشي.
ما مشي
و-
دي اس بي
و-
الحمد لله فضل
لا،
الله فاهمين.
لا والله
في اشياء
والله
مدقر لها مسوي عليها نوتس بس وقت المراجعه.
لا بس والله ما واضحة.
واضحه ذي عارفها انا واضحه. البي دي اف انا ناسي بس الطريقه اللي ناخذها فيها البي دي اف. اللي ارجع الفيديو القاها.
حلو كلامك. هنا تيجي جدول يقول لك الزيرو الفاليو هذه تعرفها نرقمها بس اوكي. تيجي جدول كم صفر فيها؟ 3 0 0 0 0 0 3 0 تكتب الواحد كم واحد في هذا؟
هذا الكاونت حقه.
حق الكاونت. تيجي البي دي اف تبغى تسال صح؟ نفس الرقم حق الكاونت تخليه بالبرسنتج. عرفت؟
قسم على 9.
طيب هذا الرقم يا عزيز بالبرسنتج كم؟
برسنتج من كم؟
من 100.
0.3.
حلو. ايكوال هذا الرقم. اكتب في الآلة هذا الرقم حيجيب لك 0.3.
كيف اكتب؟
خل حلال.
إيه،
قسم
خلاص.
طيب على 9 ليه قسم على
إيه؟
9؟ لا ما ابغى اقسم على 9.
Alright, next
يا
one.
اخي اعتبر البروجرام ما يقبل الزيرو
ها؟
ما ادري كم.
You okay
يقبل
with this?
القسمة. حط القسمة. بردك. لو حطيت نفس النسبة هنا حيطلع لك نفس الناتج. 2.3 3.5 بس انت سوي له زي ما يبغى.
We're gonna do question 8 now.
Yep, we're gonna go question 8 now.
احس السؤال هذا لازم نفهمه عشان نبني الدرجه.
Keep going.
والله مشكلة شوف اللي سواه زي كذا خلاص. اسمه كان رزق. هذا الجيم اليوم.
إيه. صالح معانا صالح.
وانا سبت احد في المستشفى وجيت. بس ان شاء الله
خلص منه.
انا بكره بتروح المدن.
حق ايه لازم تحضر. بيتر قال في تحضر ولازم تحضر. ارسل ايميل.
انت بتحضر؟
ان شاء الله. لانه راح يعطينا كومنت زياده ها.
إيه، لا تهدر يا عزيز.
Okay, better. Now the next one.
واحد فيكم.
Question 8 is all about
ترى يحضر.
image filter.
ايش يعني بيسوي؟ شفت ورقتي شفت التحضير حقي. انا بالنسبه لي فاطمه.
Okay. Filter.
لا
So what type of filter we got already?
السكرين ما تحضر خوي راح
So
السلام
when we talk about filters, how many type of filters?
هاي
High pass filter, low pass filter, band
Yeah.
pass filter.
Yeah.
Okay, we're gonna do that as well in here in the image. So you all have low pass, high pass, and all kind of filters. Now the most common one will be a low pass filter, and we use low pass filter for smoothing the image. So when we use the filter, let's say this is your image. It's an array of pixels, right?
Yeah.
So we usually filter by called a kernel, which is like 3 by 3,
Yeah.
sometimes 5 by 5
Yeah.
matrix. If you want to filter this pixel, we apply this one onto the 9 surrounding pixel. Because
Yeah.
this one is not 0 and 1 anymore, it's a number, right? It's a number. So the operation will be, we take A, B, C, D, E, F, G, H, I here.
Too busy.
So we multiply A by A, B by B, C by C, D by D, E by E, F by F, G by G, H by H, I by I.
Okay.
Add them together, they get you the result, the center one. So the center one here, called the new E, we equal to
We have to block.
plus DB, yes, CC, DD plus II.
Excellent. Good.
So you do one by one. So the top one will correspond to top one.
Mm.
Next one, next one, next
Yeah,
one.
yeah,
next
good.
one.
Lee, this what's called what kind of filter?
It basic filter.
Basic filter.
Yeah.
So
Depends on this kernel. There will be low pass, high pass, low pass. whatever.
We can know the type from
From
after
this.
that. Yeah.
Right. So you change this, the image will be changed by different type of filter. Yes. So the first and easiest one you got here will be an average filter. Average filter is 1/9 of 111, 111, 111. This one is called average filter. Or you can draw it in the other way. It's 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, and so on, so on.
Ooh.
So I can just put 1/9, then I put
Yeah,
1
yeah,
inside.
yeah.
So it's the same thing, okay? So they are exactly. Now, what effect on this image over here? So if I substitute constant A, B, C, D, E, F is 1, 1, 1, 1, 1. I have the new pixel here we call to 1/9 F.
1.
A plus B plus C
plus
plus
B is plus C.
plus
Yeah.
I, right?
It doesn't affect it.
Yeah.
What is? It's an average. The central one will be average of the surrounding and including that one.
Yes.
So you average them. And then you go to the next one here.
We have to add.
You add this thing together, right?
Yeah.
Then if you consider this one, you add this one together. So the central one will be the average
Yeah,
of surrounding one, including that one as well, if you use this filter. So what effect on this one? What effect when you do averaging? Why we do averaging?
To know.
To average the middle one.
For what? For the purpose?
First, I know the filter. If it's
We already done this before.
smooth,
Smooth?
images.
Yes.
Small images and
Reduce the noise.
the noise. Yeah.
of the image. This one called moving window average. Remember that?
Yeah.
Question 4.
Yeah. before.
Moving without what?
Moving window averaging.
Window.
This one called a window.
Yes.
Because you do this, then you do this, then you do this, and do this.
Yeah.
And then next one, next one, next one, next one. So imagine that window put here and you move the window around the image
Uh-huh.
and you calculate the new image.
If we found the last from this side, how can we?
This one?
Yes.
0, 0, 0.
0, 0, 0.
Yeah.
Wallahi,
Yeah,
good.
0.
Good.
Oh, good.
Hello, assalamu alaikum. All good, Ili. Hey, rock.
So in terms of, this one is the basic representation of I, B, C, D, E, F. But let's say I give you an arbitrary pixel. An arbitrary pixel with coordinate x and y. This one is x, this one is y, right?
Yeah.
I can represent this in terms of coordinate x and y, right? So the image, the new pixel here, x and y. So let's say the function f, x and y 1 will be equal to 1 over 9 of,
A plus B plus.
yeah, I will be the last pixel, right? How do you get that pixel? You need to add
X, Y.
y, subtract the x. Because this one is xy, right?
Yes.
If you want to calculate this, it will be x minus 1. Yes? And this coordinate is y. So this one will be y plus 1.
Minus plus 1.
This is y. This one
Yeah, good.
x. It doesn't matter. That will be the other side opposite as well.
Mhm,
It doesn't
mhm.
matter. It's plus or minus. So you can say f of x minus 1, y plus 1 plus b. B will be here. So will be x will be the same.
And
y,
y
is plus
minus. Y?
1. Plus 1. Here's y this side. This is
Yeah.
y. This is y. We want to calculate this.
Yeah, excellent, excellent. Got it,
Yeah.
got it.
And then similar, this one will be x plus 1,
Y
plus 1.
plus 1, yeah.
And so on until you all the round, and remember including f, x and y as well, including that as well, right?
Lisa, tell me X going like this, minus. From here to here,
X is
minus.
increased this way. If you go back, you should find
It's
it.
minus, okay. And Y, it's going like this, it will be minus here.
Yeah, because x, y go this way.
Okay, okay.
Well, it doesn't matter if
على
y go
أساس
this way or y go this way.
على أساس إيش؟
وش على أساس؟
على أساس إيش تنقص وتزود وده؟
عشان
على سيبك الأسلام، لا على أساس إيش؟ من إيش البيسك؟ من فين أبدأ أنقص؟
المربع، انت المربع.
أيوه.
ما انت لما ترجع كذا تنقص في الاكس،
أيوة.
الواي راح يطلع لفوق.
أيوه.
طيب لما تنزل لتحت انت الواي راح تنقص.
على أساس
صار
المربع.
الجمع في
المربع
في
ولا
النص.
السهم؟
في النص تصير جمع.
أيوه.
Now it doesn't matter if you go y this way or y go this way, because you will including this one and this one anyway, right? So it doesn't matter if you go up and go down, you will add 2 points already. If this one is plus, then this one is minus. If this one plus, this one is minus.
Yes.
So it doesn't,
Yes.
it doesn't matter too much, right?
Okay.
Alright. So you have average filter, that one. Some more filters here. This one is called white average. So you got
White?
white.
Weight average.
Average is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, multiplied with 1 over 9. Yeah. The other one is weighted average.
So 1 over 16.
1 over 16 of 1, 2,
2,
1, 2, 4, 2, 1, 2, 1. You know why is 16 over here? Why is it 16 over here?
Because
16 will
the
be
four-
sum
the
of
four-
all things in here.
16 here.
If you add everything together, it will give you 16.
16.
Because we don't want to increase the intensity of the image, right? If you add 9 terms together, you should divide by 9. If you multiply this one by 2, you divide by 2. Right?
Mm-hmm.
So the total intensity of the image will be stay the same. So whatever numbers in here, add will be these things.
ليه؟ ليه؟
Yep.
What intensity? What does it mean?
I don't want to increase the brightness of the image.
That what?
Brightness.
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 Brightness. Yeah.
That we call intensity.
Intensity. فاهم؟ أفضل اللي قاعد تسأل في الفيديو.
Okay, so if you can see that this
كم
is
مرة
the
قال
original
لك
image.
بس ما فهمت الحين قلت اسأل عليها.
دققت عليها.
You have noise reductions.
دققت عليها متى؟
انت الحين سألت.
يا شفتها في الفيديوهات كم مرة سمعتها فبعرف ايش هي.
Now this one is called Laplacian marks. So this one is quite different to this one. Okay, so you have 0, 1, 0, 1 minus 4, 1, and 0, 4, 1, 0. What thing's gonna do? It's gonna do
يا أخي ورانا واحدة.
image enhancement. So they're gonna increase the
اللي كان
contrast
نتكلم عليها فوق على اليسار.
and give the image look better. Increase the contrast. So
For
they use Laplacian marks over here.
which one? All of them?
All of them. So can be this, can be this, can be this, can be this.
Why the ABCD there?
This one?
Yeah.
This one is image I. Filter marks you to implement Laplacian. B with this one, which is this one. Okay? So this whole Laplacian marks. So it doesn't matter if the name, it's the numbers here is important.
Yeah.
So what they might ask you in the question is you need to apply this into the image. So you need to do operation like that. Right? So that pixel corresponds to the first constant. Next one, one by one.
Yeah.
We gotta do that in this example. It should be better with this one.
This is the moon.
Yeah.
Yesterday.
If you can see the difference between this and this.
Did you
This
see
one
the
is
one
using
yesterday?
no. This
Yeah.
one using Laplacian
It
marks.
doesn't have time.
It's banned. It's banned yesterday.
Okay. These are two other Laplacian marks. So you can see that easily if you see the central one.
خسوف يا شيخ.
It's completely different with the surrounding one.
خسوف بس
خسوف.
ليه yes ليه؟ Yeah, welcome.
The Laplacian always have the central one
Yeah.
Yes.
bigger than surrounding one.
Yeah.
So it's all about Laplacian marks. The next one you see here is the edge detections marks. So you have 0, 0 only in the horizontal here, see? Or the 0, 0 go into vertical line. So it will detect a line. So line detections marks. So if you take this, it will give you this. Or this gonna give you that. Okay. And so you have maybe 2, 2, 2 go this side, 2, 2, 2 go this side, 2, 2, 2 go this side, or 2, 2, 2 go this side. So this one will enhance the line going this side, or this side of the image. Right? So for example, I give you that image, you apply that the marks, so you got this.
But nothing black, Ali.
You can't see that. All right. So just introductions of what you can do with this type of filter. Okay. By changing the number, you got different type of filter.
Yeah. He won't ask about the type of the filter, yeah? Or he may.
Later. Can you see this?
Yes.
Yeah. Home. House.
And this is the line detected from this, from the months. Okay. So that is the first part of the.
الكاميرا تشوف أحسن مننا في اللي قبل شوية. كان واضح هنا إيش فيه. تعال.
Next one.
شفت الهابس؟ مكان اللي تحت ما هي واضحة بس الأول صورة. هنا مرة واضحة كانت. شوف الحين راح تفهم. شوف صورة مظللة هنا بقوة تشوفها هنا فاتحة.
Okay, the next one we're gonna do is frequency domain image filtering.
كان لونه أحمر مسقمر بس. حق ساعتين قاعد بس. مو قاعد محرق ولا شيء.
مو خسوف يعني.
إلا خسوف.
بس أول مرة يجي السؤال من كم.
وترى
Now, frequency domain
بس
filtering. For example, if you have that signal in time domain, right? You can do Fourier transform. Fourier transform to get a frequency domain. So frequency domain will look like that. Yep.
Yep.
Fourier transform. Now using that, we can do low pass and high pass filter. Let's say you apply a low pass filter, then you remove this, and you keep that. Low pass filter or high pass filter the opposite way. So you can do that in the frequency domain, similar to discrete signal. Let's say you got discrete signal like that. You're gonna do a discrete Fourier transform.
Transform, yeah.
So you have a discrete,
And take some, remove some.
and you can put the low pass filter.
Yep.
Do some. Now you can do this with the image as well.
How?
Okay, because the image is actually a number. So if you take a line like this, it will give you something like that. But this one is a number. Right? 1, 2, 3, 4, 5, 100, 200, something. So it's just like that. But it just take this one on top of the other, on top of the other, on top of the other one. So one-dimensional signal give you one-dimensional Fourier transform. Two-dimension give you two dimensions Fourier transform. So Fourier transform will look like this. So there will be a central frequency here. It's called something like that. So you got high frequency term, something like that. So it could be something in here. It's the Fourier transform of this one. Have you seen about MRI image?
Yeah.
This one. Magnetic resonance imaging, right? Which is this one. So you take Fourier transform the image, then you try to see what is the image over here. So it's about Fourier transform. You take Fourier transform of the image, then you do the operation on that frequency domain, and then see what effect that you have. So you have a definitions of two-dimension Fourier transform. This is one dimension, so I think this one is already straightforward. The Fourier transform of the rectangular is a sinc function, right? PT into sinc. And this one is discrete Fourier transform. So it's better to remember this formula because sometimes it asks you in the questions. So it gives you the image of f, x, and y. It will calculate the f of u and v. U and v is frequency. This one will be equal to sum of f x y e to the minus j2 pi ux and vy of the element. This one is not quite difficult because if you still remember the definitions of Fourier transform will be integration of ft e to the
to bar j omega t.
Now discrete Fourier transform fn gives you f omega equal to sum of fn e to the minus j n
Gen Z
pi
by
over n
for
whatever.
the discrete one.
The discrete Fourier transform. So this one is just add another dimension to that one.
Yeah.
Okay, one discrete is here. J pi x over m. So this one and the e one here. So we all talked about two dimensions. So it's better to remember this one. So for example, can you see this?
Yeah.
This one is the picture of a rectangular. If you take Fourier transform of this, now imagine that this one, if I take the line from here to here, vertical line, I will see something like that, right? So the Fourier transform, I expect to see something like this, the sinc functions. Here you go. This one is the sinc functions. See the bright and black and white and black and white, black and white, black and white.
Yeah.
So if I plot them, I will see something like that. This one. This one. The line here will correspond to the Fourier transform at the middle line. And similarly, if I draw this line, I expected this line. This one.
Okay.
Alright, so after you have the frequency domain of the picture, okay, something like that, you can have a low pass and high pass and any filters in here. For example, low pass. What low pass look like? You allow the frequencies to come in, don't allow the high frequencies to depart. Now this one is a low frequency here, this one is high frequency. Remember two-sided spectrum?
Yeah, it is suspect.
The middle one is low frequency, this one is high frequency, which is this one is low frequency. So you will multiply by some functions that will make you look like that. This one will multiply by 1, let's say. This one you multiply by 0. Like that. You multiply by 1, this one multiply by 0.
Remove the.
So which is you remove anything outside of this circle.
Yeah,
Like this, just like this.
Just focus on.
Yep, except for this is one dimension, this is two dimensions. You can it go every direction, right? So this one is the low pass filter version of this one. So as a result, the image will be blurring because you do low pass filter.
Blurring.
Blur.
Yeah,
Okay, so I give you an example For example, this one is original image of the rectangular.
Yeah.
If you take Fourier transform, you got, well, this one is not quite easy to see, but this one is actually like one. With the sin function, go black, white, black, white, black, white, black, white, black, white, black, white. So going this way. Then you apply a low pass filter. A low pass filter which is 1 in here. 1 means white. This one means 0 means black. So you simply take this term dot. So whatever 1 will keep here, whatever 0 will be
Remove.
0. So there will be nothing outside here. Nothing. Okay? It's only this thing. And if you take inverse Fourier transform, this one is a blurring image of that one because you remove the high frequency already. Yep.
What's
Yeah.
with blurring?
Not sharp.
Not sharp?
Not sharp.
Not sharp. Not ما في أشكال غريبة.
Blur. Like you take the picture
Yeah.
when you moving around. It's called blurring.
Yeah.
I get it.
And you got the word. Yep. So you can see
It's clear.
what the component of the image here, right?
Uh-huh.
Yeah. So the low frequency gives you the shape of the image.
Uh-huh.
High frequency gives you the edge of the image. The edges. If you want a clear picture, you need high frequency. If you
Yep.
want the shape, you just need low frequency. Yes. Now the same image. What happens if you apply high pass filter? What high pass filter look like? Like that, right?
Yeah.
You remove the low frequency, keep the high frequency. So what you need to do, you multiply this by black,
0.
0, yes, and multiply everything else by 1.
1.
So it will be look like this.
Yeah.
Yep, so they will do the same thing here.
So, but
You got the image, you got Fourier transform of the image, take the high pass filter. So multiply the central by 0, multiply outside by
the
1.
whole will be black.
Not quite. You got something here. You see something there?
No.
A small.
Yeah, small line.
Yeah. So there actually some things in here, but in the middle is completely black. You take inverse Fourier transform, you only have this. So you don't have the actual shape, the solid shape, but you have the edges. Right? So you see two components of the image over there. Low frequency gives you the shape, the color. The high frequency gives you the edges, the clear detail, the high resolution things.
So it's the high filter is better than.
No, it have to be both. High filter then like if you're wearing glass, this one will be low frequency. High frequency.
You know what I mean?
Yeah, you got what I mean. This one will be your low frequency.
And this will give you high
Yeah, gives you high and low
and low. both
because
the
you
same.
can't make the low. I can't give you the example.
I get it, I get it.
You got it? The low frequency is more important than high frequency. Low frequency, at least you can see something, right?
Yeah, you can see something, but when you put the high frequency on it, it will be clear.
Yes, which is done
Ali, when did you start wearing glasses?
10 years ago.
10 years ago?
Yeah.
Uh-huh,
Okay, so this one is another example. It's not. It's
yeah.
hard
No,
to
this
see.
one like
Can you
sheep.
see this?
Yeah, like yeah,
Yeah.
sheep.
Yep. And if you take Fourier transform, you got this, and you take the low pass filter. So you have this one. So you just keep the central part, and that gives you the blur image of the ship. Blurring.
Uh-huh.
Yeah. And if you do with high pass, the original image, Fourier transform, take the high pass, multiply the middle by 0. So you will remove the middle. Can you see that? The middle here is 0 in the middle. And this one is the result if you take high pass filter. Alright, so it's the basic high pass and low pass. This one is the thing that I explained to you. It's just a 1 and 0. Okay. So in the middle is 1, surrounding is 0. So the function will look like this. So this is the easiest example. Do you have another one?
Do you know a small, bigger, small, bigger? It's like when you're going to test your eyes.
Yeah. You have different type of filter here, and one of them will be in your exams.
One of them?
Yeah. First one is a basic 1, 0, 1 and 0 filter. The next one is a Butterwood filter.
But
Butterworth.
Butterwood filter.
وعليك لو باص filter.
And Butterwood filter have that equations to calculate what is the thing that you have here. So basically, you not just multiply by 1 and 0, you multiply by some constant 0.9, 0.7, 0.6. And if you go further away, you multiply by less. Okay, so it's not just simply multiply 0 and 1. How much you need to multiply? Based on that equation. That equation you need to remember. Sometimes asked you in that.
Which one? The above or down?
DUV. 1 over 1 plus
Plus
DUV
DUV
divided D0
by D0 power.
لازم نحفظها.
And it's a number
اللي
of the
فوق.
order that you have. So you got first order Butterwood, second order, third order, fourth order Butterwood filter. So you just need to substitute, and here is a number of order. D0 is the distance of the cutoff frequency from the origins. Okay. So how much of the cutoff frequency you want? I want to cut off 5 pixels. I want to cut off 10 or something else. So this one usually going to give you. And DUV is the pixel that the coordinate that you want to calculate for D. The one that you need to calculate. Anything else in here? Do you have? This is the questions. Probably going to give you. So this one, DUV actually equal to square root of x squared plus 1 squared, u squared plus v squared. And this one is the example. It's actually in the past exams. This one. This is exactly. Or actually they changed the number a little bit. Design the Butterwood low pass filter with sine 100 by 100 with cutoff frequency phi and require the gain of filter is greater than 0.9 with the dixit u square plus v square less than or equal to 4. This one is the gain. Okay. So all you need to do substitute into this equation. Yep. So you need to calculate design a Butterwood. So you need to calculate how much order of the filters that you need. So all you need to do is substitute into this equation. DUV is actually here. So it's already gives you this one equal to 4. And you have D0 is 5. You substitute in here, you have 0.9 equal to 1 over 1 plus
4 over 5.
4 over 5 power of 2n. Then you calculate n.
So
It's greater than. So gain of this one is greater than 0.8.
how can we take math? I know it's math.
That's, yeah.
What's that? I forget.
Come on. Take it on top.
Yes. Yeah, it will be 1 minus.
0.8 times 4 over 5 by 2 and let's say it's equal to 1. Easier now. Then you can calculate this. Yeah. So you have 0.8 times 4 over 5 will be 0.8 as well. But 2n equal to 1. Take it on the other side, so it will be 0.2. So we get 0.8 over 2n equal to
0.2.
2 divided by 0.8 would be 0.25. 5.
Yes.
So 2n we calculate by log of 0.28 of 0.25. 0.25 divided by log of.
So and 2 will divide it.
Yeah.
So just.
Yeah. So you have
أنا ممكن اليوم تنزل.
4. You have calculator and you see the log and divide by log.
Good.
Log of 0.25.
نزلت؟
قام وضحك نزلت. الله بس أبس وجهي أنا عشان أصدق إنه نزلت.
6.21.
نزلت في
This is 2n equal to 6.21, so you can calculate n equal to 3.1. Now you need at least 3.1 order
كيف تنزل؟
to give you that. Now you don't have 3.1 order, right?
Yeah.
N is an integer order. you
So
need
make
to
it 3.
4.
Ah.
So you need at least this to get that. So if you put 3, you not get enough. Okay?
Yes.
You need to line up. So or 4 will be the number of orders you want. So this one is the equations of the field after you substitute n equal to 4. So you got 8 over here. Right? Pass exam. This one is a pass exam question.
Why we put 8?
Because
To
it's
multiply 4, yeah, 8. Sorry.
2n.
Yeah. 10. I thought it's just the N.
Oh good?
Oh,
So it just surround.
This
that.
example is
Yeah. Then you have high pass filter as well. High pass filter is the opposite.
images.
Yeah, opposite 0 here, 1 in there. Then you have high pass filter Butterwoods as well. So the difference is you take D0 divided by D.
Yeah, that's 1 D divided by D0.
Yes,
Yeah.
make another way around. That's it, no problem. So you still use same kind of calculation here for high pass filter. So you just take this one back in here.
It will be 0.8. It will be something like
Yeah, I think it gives you something like
4 divided by.
oh, it not give you
Example?
So mine gives you an example. High pass.
High pass. Hey, high pass
Okay.
filter. So example.
But the idea is the same.
5 divided 4. How much will be? Point.
5 by 4.
Yeah.
1.24.
1 point. Yeah. So the difference will be 1.25 just.
Okay, there's another one. One more.
1.25. Yeah.
Frequency.
All of this picture and stuff.
What is this one is advanced DSP architecture. Oh, you were studying here.
Huh?
This one supposed to be in another
Subject?
subject.
Why he give us?
Design of DSP architecture.
It should the water.
It's called DSP 2.
The advanced.
Design of
Advanced
DSP
DSP.
architecture.
Shit.
But now CGM include everything. Okay, the next one.
You will find that.
Probably got asked you what type of filter is this. Oh, I don't have the. Hey, got this one. This one is also a past exams. Form a filter with every x pixel and is for neighbor pixel. Find its discrete Fourier transform and show that the filter is a low pass filter. So they give you this equations. Now remember this?
Yes.
The output gxy is 1 over 5 of the f of the x
Minus 1.
minus 1 and the y, then the x
Center.
and the y minus 1,
Nine.
and xy center x y plus 1, x y plus 1. So basically, the filter will look like this. Take averagings of 1 over 5 of 0, 1, 0, 1, 1, 1, 0, 1, 0. Okay? This is your filter. As you need to prove this one is a low pass filter. Okay, we can draw this in terms of formula, right?
Okay.
So let's say this one is xy.
Okay.
So the output gxy will be equal to 1 over 5 of 0, nothing. This one will be
X
this one is x, this one is y.
It's just the same X.
Same x,
Yeah.
y plus 1.
One. Yeah. One.
And this one will be
Minus X minus 1.
minus 1, y,
Y plus 1.
y, same y.
Y is same, yeah.
Plus this one, f of xy, plus this one, f of
Opposite.
x plus 1, y. And this one will be f of x, y minus 1.
Yes.
Yeah. So this is one way to represent your filter. So it can give you two forms. Might be this,
Or
might be
this.
this.
I have to represent it.
Yeah. So this one is gonna give you last year. This one gonna give you 2012. A Jan style. But it's the same thing.
يقول لك يعطيك المربع اللي فوق وانت تطلع هذه يعطيك اللي تحت.
طلع المربع.
لا بس ما طلع المربع بس حله هنا. هذا لا حل ثاني. how come we solve
Now,
this one?
Next one, you need to prove this one is a low
pass
pass
filter.
filter. Now you need to do discrete Fourier transform of that filter. Okay, to try to find the transfer functions. Now, discrete Fourier transform G of u v 1 over 5 f. Now, if you look at this, you just consider this one, it's a shift theorem, shifting. Okay, what is shifting in,
Low pass filter.
now what is shifting in Fourier transform?
Shifting
F
like f
of t minus,
minus t
t transform to
e
f omega e to the
multiply with the j
omega t.
omega t.
This one is
Shifting.
shifting theory, right?
Yes,
Now,
shift.
I can do the similar one in discrete Fourier
Yeah.
transform as well. T
Minus
t.
t
If the original f of whatever u or v over here, multiply by e to the minus j
j
and pi over whatever n and
t.
So this one is not important, but the important is the t over here. It's actually multiplied. So I will do 1 by 1 with the shiftings. Yep. So if I got the first one here, if I shift it by minus 1, I will multiply by 2 pi ux over m. Okay. Now this is term. The x, we got the term of ux over m. The y will shift by vy over n.
Okay.
Now, when you shift by x, you including this term. And shift it by y, you including this term. This one should go
When
with
both.
e to the minus j u and e to the minus j of something.
When it's both, like in the corner.
Okay?
When it's both.
Why?
Shift
You
it-
multiply both. You shift it both. So this one, alright? I got f of u v, the original one, multiplied by y, shifted by minus 1.
So we use E minus Vy.
No minus because you shifted by t, you got a minus. So if you shift by plus, you don't need to plus over here, right? You need the minus over here. E of j v y over n. Yep, and so on. Plus
Plus.
this one. Now I can
Second
just make this one as common factor, right?
Yes.
Because every time I will got this one anyway. So I will take this one off to be a common factor.
شيك على الاسد ولا لا؟ شيك على.
Yeah, look like that.
Okay.
Yep.
So the
this one.
second one will be E. Oh, you want to
M. This one will be 1 because
Oh,
that
okay.
one will be simply
That's one. It's minus
J ux over n.
Yeah, because it's shifting by x directions.
Why we didn't remove it minus?
Yeah, the minus will become a minus. The minus here.
Oh yeah, will be plus.
Yeah. Plus,
Yeah.
plus minus minus.
Good. And the
Actually,
second one
sorry,
will be
we're
one,
missing a
just
2
one.
pi, right? It should be a 2 pi in this one. 2 pi, 2 pi. This one is 1 because simply
Yeah.
Fourier transform.
Plus,
Sorry.
same that one a minus, plus
ux
Over
2
m.
pi over m. This one
plus
will be
a minus vy over n to y
n 2 pi.
will be minus. Yeah.
All good?
Good.
Oh,
But now you can group the common things together over here. Yep.
Can we delete it plus or minus or not?
No, you can't. You need to do something like this. Cosine f alpha equal to e to the j alpha plus e to the minus j alpha.
بس أول
Divide by 2. So this is where you need to look at. You look for the same thing except for plus and negative j to give you cosine. Like this. For example, in here, you can see which term.
yeah,
You can
because
see this one can be combined with
that's
this
one,
one.
yeah.
See,
And the
same.
second one with the fourth one.
Yeah,
Yeah.
to become a cosine.
Yeah.
So
it's-
2 cosine actually. So you guys gives you 1 over 5 f uv f 2 cosine f. This one, right? Vy 2 pi over n plus 1 plus 2 cosine f ux 2 pi over m.
جميل يا أخوي.
Yes?
Excellent.
So this one is your transfer functions. Okay. Now from transfer function, how we know it's a low pass or high pass filter? For example, I give you this transfer function h omega equal to 1 over a plus omega square. This one is a low pass or high pass?
Low pass this one.
Yeah, why?
Huh?
Why?
What? Why?
What
Why?
is a
that
low pass
this
or high
one?
pass?
This one?
Yeah.
Yeah, this one low bus
Why?
because the A
No.
high bus.
No, because
It's a low pass because when you increase omega, it's on decrease.
Sorry, because the omega. Sorry, well, I swear I know it. Yeah, before. Yeah,
Because
sorry.
you
because-
increase frequency,
Yeah,
the transfer function magnitude decrease.
yeah.
Same as in here. U and V is your frequency. Okay? U
Okay.
and V is your frequency.
لا، أنا
What happens if
علمتك
you
إياه
increase
قبل
U
كده.
and V?
الحين ناسيها. ها؟
What happens if you increase U and V?
U and
the
V.
HAI will be decreased.
The U and V
The
increase,
frequencies
the cosine will be
decrease.
Increase. No. The cosine will be increasing.
Increase.
Why decrease? Increase.
cosine. Come on. How much cosine of 0?
1.
How much cosine of 90 degrees?
90 0.
Ooh.
Another
Zero.
way
One.
around. Yeah. Sorry.
So cosine will be decrease.
Decrease.
When you increase this one, cosine will be decrease. So see the effect? Increase frequency, decrease the transfer function. So it will be a low pass filter.
Low pass.
Yeah. So yes. So again,
What about high pass filter? What?
Another way around.
it will be sine.
Sine.
And the omega will be another like
Yeah.
above.
Another way
it.
around.
Yeah.
كيف راح ندخل الساين؟
بالماينس في النص اظن الساين. E minus E اظن ماني متذكر. All of them minus ماني متذكر.
ليه؟ How can we know it's sine?
شو مثلا؟
Because you give us this one cosine, we use it like cosine.
Yeah.
هذا المكافأة.
Okay, it's high pass. Yeah, I gotta give you sine everything.
Yeah, sine
Or
another
something
way
like
around.
this. It gives you a 1 minus 2 cosine. Something. U and V, right?
This one I'm going to solve it, yeah or no?
No. What happens if you increase?
Increase what? ايش هذا؟ sine?
This one will be smaller, right?
Yeah.
Yes.
This one will be bigger.
Yeah.
So it's a high pass.
اوكي بعدين later we will know it.
Okay,
Why
well,
is so confused?
Yeah. No. Okay, yeah.
Completely
إلا
music.
yes, yeah. صح.
Not completely
Correct.
music for me.
Careful. This one is low pass.
Yeah.
Increase omega, decrease the gain.
No, increase the omega, decrease the gain. Yeah.
Alright.
Okay.
This is a high pass.
Opposite.
Increase omega, increase the gain.
Yeah. No, decrease the omega. Lee. Or yeah, also you can say
Increase
that.
omega.
Increase,
Yeah,
increase,
also you
increase.
can say that. Yeah.
Yeah.
I know this one.
خطير أنت.
Right, كيف أعرفه بال
How about the sine equation?
It's same thing.
No. The above one, like
This one,
with EE, yeah.
sine V J minus J L2.
قلت لك بالماينس. Yeah.
So
Minus down, yeah. تبغى نكمل ولا
نزلت المكافأة خلاص؟
تبغى نكمل ولا كيف؟
والله أبتحم ما أبدو أي واحد.
Right. Next thing we're gonna do parts example. Ready?
Ready.
Question 8, 2013.
شيك على شيك نزلت؟ عندك ما
الا
نزلت انت لحسابك ولا لا؟
إيه نزلت غصب.
شو؟
نزل.
والله نزلت يا أخي. انت ما تشيك ليه ما تشيك على حسابك؟
ما نزل.
نزلت.
لا تقول تفجع فيها، سوي ريفرش يا اخي. ياك بابو.
ترى بالماينس 26 سحبوا 26 حقهم يعني.
قل والله.
Okay, first one.
خذيت $6 سحبوا مدري.
24.
Okay, how about this?
Look good.
What this? Is
No,
that
no,
the
come
one
on,
that we
come
talked
on,
about?
اي والله
لا لا
نزل.
لا.
حساب 2500.
Come on, this one.
ليه ما كلمتني اقول لك؟
يا أخي أصبر شوف هنا.
اوكي.
لا ما
Find the Fourier transfer function of theorem, determine each low pass or high pass, and describe your reason. Come on, what this? Is it the one?
This is the
Yes,
the
this
you
one
give
is
us.
actually the one that we just done it. Yeah. So
Yeah,
it's
exactly
got
similar.
exactly the same. So it just gives you.
This
Yeah.
The low one, yeah?
We don't know it's the low or the high.
No, it's exactly the same as.
Yeah, it's low. I think.
Yeah.
Alright.
This
Yeah, low.
it's a low pass. So you copy exactly this, put in there.
1/5. Yeah.
This one. So rather than give you this, he gives you the matrix. 1/5, 1/5, 1/5. Alright?
Alright.
So question 8, part A is this one. Exactly the same thing. Exactly
Good.
the same thing. Part B,
That question-
2013?
2000 what?
13.
Part A. Question 8, part A.
Part A. So you go to lecture page 40.
Okay. Part B.
Lecture 8, page 40. Alright, part B. Give you the filters, gives you the equation, and asks you the marks representation. So asks you something like this. I give you two ways. Happy?
In the same time?
Yeah. This one gives you the matrix, asks you the form.
Yeah.
Then,
And one question, two ways.
yeah. So this one gives you the equation, asks you what the matrix look like. Now what the matrix here look like?
For this one?
Yeah.
Okay.
This one is XY, okay?
XY. Okay.
What is the marks of XY? Exactly.
In the
Ah.
bottom here.
Where is X and Y? Come on, you can see that.
Final one.
Yeah,
2F.
XY.
2,
Alright.
yeah.
So what happens if you this way? decrease the x and keep the y.
This one will be
X minus 1 and y.
yeah x decrease.
Yeah, f 1.
The
The second one. Minus f x 1.
Minus 1.
Minus 1. Yeah,
minus increase minus which one?
This one is
الثانية
x minus
الثانية
1.
minus f
Y.
x minus 1 y.
It's x minus 1. Y.
فينها؟ what is it؟ أكد. خلاص هنا قدامي دقيقة just a minute. شو اللي
This
فوق؟
one is
Easy.
easy stuff.
This one. اللي في
How about
النص.
this? X plus 1. Y.
Minus 1.
X plus 1. Y. Okay, minus 1. Opposite here. Okay.
على آخر
easy
شيء.
stuff. How about this? X.
This one.
Y plus
X
1.
X y plus 1. It will be plus 1.
Minus 1.
Minus 1.
Minus 1. So similar should be here with x, y minus 1, right?
Okay.
Yeah.
And-
Minus 1.
Here 2.
And f x plus 1. How about this one?
This one.
Ah,
Y plus
X.
1. X minus 1.
X minus 1, y plus 1.
Y plus 1. It will be minus 1. Minus 1.
Minus 1.
Yes. Minus 1.
And should be minus 1 over here. How about x plus
Two.
1, y plus 1?
2.
Two.
X plus 1 or minus X
Two.
plus 1.
2.
And x minus 1, y minus 1.
No, Lee.
Okay.
This one plus plus, yeah?
Yeah.
And this one?
Minus minus.
2.
Is it?
Diego.
Yeah, it's 2. It's 2.
Right.
It's 2.
So this
Yeah,
one is the
that
marks.
one is there and this one is there.
Yeah.
I confuse those two.
So this
Good.
one is the marks of the filter. Right, so just one by one in there.
Okay.
Easy?
Easy.
Easy. Apply the marks for the image and obtain the output image and use them to identify the operation of the filter. So you're gonna
Part B هذا.
yeah. So you're gonna see what this filter doing in there. What that filter gonna do? You got two, then this one. Come on, we already done this before.
If we get the 3 numbers.
When you
there.
got 3 number in this or that,
Yeah. It's gonna be like what did you say?
edge enhancement.
Edge. Yeah. It will be like a circuit.
Edge enhancement in a 45-degree line. So whatever is 45-degree on the image, it will enhance that one.
Yeah.
So we see-
Yeah. That's one. It's not clear. It was like block. Yeah. So I know. Yeah. You should.
But where you need to see what is effect of these 2 images. So you got 2 images over here.
Yeah.
Image 1 is 1 for x equal to 0, 0 for other y. Right, so that's how you got the image here, like that. So x equal to 0
Yes.
when fxy equal to 1 and x equals 0. So this one is your x. So this one you got a white, and this one you got a black. Yes?
Yes.
Yes.
Yeah. So let's say you got a 0, 1, 1, 1, 1, 1, 1, and 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, so on, so on, so on. This one is your first image. What happens if you apply this one to this image?
Where we put it?
Where you
It
put
will
it?
change.
So
To
the first one will be
45 degree.
No, let's apply it and see.
Okay.
what-
Let's apply. Let's apply. Sorry.
Okay.
Let's apply.
I'll make it bigger.
Yeah.
So G. So let's say I have this image. This one is 1, 1, 1, 1, 1, and 0,
Yeah.
0, 0, 0, 0, 0, 0, 0, 0, 0. I want to apply this on here. So what is output of the first one?
Apply 0.
When you need to apply this one, you need to apply like this, right?
We put it in the, yeah, for
So everything else is 0, 0, 0, 0, 0, 0, 0, 0 outside.
Yes.
So this one will multiply by 2.
And minus 1.
So 2 is here and minus 1 over here. So that gives you 1.
1.
Yep. How about this one?
This one,
This one, yep.
it will be
This This one will be look like that.
minus 1, 2,
Minus
minus
1,
1.
2, minus 1. So will be
2.
minus 1, 2,
Minus
minus 1.
Minus 1. Minus 2.
Minus 1,
Minus 1
Two.
is minus 2.
minus 1, 2, minus 1.
Okay, 1,
0.
0.
And this
Why
will
is
be, this will be similar, right? Because it will be same, so you get 0,
Yeah.
0, 0, 0. And when you apply to this 0,
Yeah, I guess
it will be all 0 all the way here. How about this one? This one. Okay, so it's 0, 0. Now this one will be
minus
minus 1, minus 1.
What about 2?
Now this one. How about this one?
This one minus 1, minus 1, 2.
Minus 1, minus 1, 2, so will be 0.
0.
This one will be minus 1, minus 1, 2,
Zero.
will be 0. So 0, 0, 0, 0, 0, all the way. How about this one?
Lee, how could be minus 1, minus 1, 0?
Yeah, how
This one will be minus 1, 2, just 0.
Okay, let's say you consider this one, yes?
Yes.
Alright, so you need
وقر
to
على
apply
على
here.
وقر على
Okay.
Yeah, so 1 time minus 1 plus minus 1 time minus 1
yeah.
plus 1 time 2. That's 0, 0, 0, 0, 0.
Shit. Okay.
Yeah.
1 by 1.
And add them together.
Yes.
Excellent يا شيخ. والله فهمت.
Yes.
You need to do 1 by 1. So when you move to the next one, it's already zeros over here, right?
Yes.
So everything here will be 0, 0, 0, 0, 0, 0. So the original picture is a white line. The arbitrary is just a dot in there, and that's it, no more. It's black, completely black. So it doesn't do anything with this vertical line, right?
Okay.
So this one is not the type of this one. Alright, how about the other one? You got another image here. Fxy equal to 1 for x equal to y. X equal to y mean 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Yep. So if I have another image,
Lee, so we draw like this?
yeah, you need to do this. If you remember what it does, you can write. But if you not remember, you need to show what it does to the image. It's not too hard, right? Just do one by
Not
one.
too hard, but I don't know how to. No, x equals 1.
2.
Alright, let's say I got 1, 1, 1, 1, 1, 1, 1. 1, yes? X equal to 1. This is 0, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5.
Yeah.
Everything else is 0.
Lee, do you know how many squares we have to draw?
Doesn't matter. We just do 1 and 2 and then we will see the result.
احنا ليش نسويها؟
الحين نسوي الثانية otherwise الثانية لو x equal 1
وخلصنا الأولى؟
x equal 0 ايوه
خلصنا الأولى؟
Okay, let's start.
حلها
خلاص الحل حل.
إيه.
بس غلط عنده حل ترى.
Okay,
قلت
Ready?
خذ واحد. Yeah.
right, let's start. Now the first one here. First
0
one,
0 0 0 0
we need to apply this, right? Yes?
Yeah.
Okay.
0, 0, 0, 0, everything else, except
Yes,
for this
indeed.
one.
2 2
2,
2
2,
4
4. Wow. Now this one. How about this one?
0 0
This
0
one,
0,
we will
0,
need to
0,
apply like this, right?
It's 4 it's 4
So you have
minus
no,
2.
minus 1
Minus 2.
minus 1, minus 1,
Minus 2.
minus 2. And if you go further
It's not
away from
out?
this one,
Minus 1.
that only minus 1. Yep.
Yep.
And if you keep going further away, there will be 0, 0, 0 because nothing else in there
Yeah.
to give you anything. If you go this way, this one,
minus
Zero.
2. Minus 2.
وعندك هنا
Minus 2.
okay, so you need to go in line.
مدير.
that.
Minus 2. Minus 2 مدير.
So minus 1, minus 1,
Minus 2.
you minus 2. And if you go for the 1 over here,
2.
so be 6
4.
2, 2, 2.
4, 6. Yeah.
6. And how about this one? This one will be
-2.
-2. And if you keep going with this one, how about this? So we only have
-1.
Minus 1.
And if you do this one,
We only have minus 2.
-1,
Two.
-2. And how about this one?
For this one, it will be 6.
This one.
6.
6. Wow, you see that?
Yep.
Everything else is minus except for the
One.
vertical line. So you go 6, 6, 6, 6, 6 going around, and there will be 0, 0, 0, and -1. Something surrounding will be -2, and surrounding will be 0, 0. So what can you see now here? The edge is enhanced. Right? Enhanced. Because normally you have this one, if you want to detect the line, you only have a 0 and a 1 and then 0. Now, if you see this, you will see a 0 and then a -1 and then -2 and then 6 and then -2 and then -1 and 0. So you can see the edge more clearly.
Yes.
Yes? This one you can easier to see because next to the 6 is the -2.
Excellent.
This is next to the 1, it's just
1,
0.
0, yeah. It's not
Not much, right? So you can see the edge is more clear
clear, yeah.
in the 45-degree direction. So this one, to enhance the edge at 45 degrees only. It doesn't work with the vertical line like before. It only works with 45 degrees. All right, how is that?
Excellent.
I understand. it.
The previous one, what you solved it here, the squares, the previous one.
Yeah.
Is it the answer or this one?
No, no, you need to do both.
Both.
To see, use them to identify the operation of the field it performs. So this one is actually the example in the lecture here. I'll show you in the lectures. This one. This one. Line detection marks.
So we solve it like this one.
So it's 45 degree line is okay 2, 2, 2. So this is the example. You will have a look here. See the example. Let's say I got the image here,
Yes.
and if I apply the 45 degree, I only have this line comes up. So it's only detect the 45 degree.
Yeah.
Yes.
Yep. Everything else is black.
Black.
Only the 45.
Just the line 45 degree.
Yes.
Good. بس لا الخط هذا.
And probably another one here, but this one is not exactly 45 degree. So it's not quite. This one is exactly 45 degree.
طيب ليه
How?
I understand it completely, yeah?
Good.
But when I'm gonna write to him the answer,
You write this. The operations, do you write this one first? This is the marks.
yes.
Then you do operation with the one I got before on the 1, 1, 1, 1, 1, 1.
Mm-hmm.
It's a result here. 0, 0, 0, 0 everywhere. So you can say this one here.
So
it will take
time, this one.
Yeah.
It's big.
Not detect or no effect. So we don't have anything out of the image if we do with vertical line.
Yeah.
We do this if we say the line is enhanced or is detected,
It's 45 degree.
yeah, and it's enhanced, the edge is 45. So this mark's gonna do this. So I recommend that you study the marks over here. One of them probably is including the line detection marks. The this one is detection at the edge actually, like, and you have a line detection as well. If you have a 0, 0 on one side and the other side, and you have this one as well.
each one different.
Yeah, you can see the difference. Can you see the difference?
Yes.
Yeah. If I do the 0, 0 on this side, the edge on this side will be enhanced. If I do 0 on this side, the edge on this side will be enhanced. See the difference?
Yes.
Yeah.
Yeah? But it's a bit harder in this kind. It's better when you do
Right,
so.
بس كم تغير انت من هنا بس بانك قاعد تغير البكسل.
Okay, so there's last year exams. All 8 questions, we already done that. And if you have a look at 2012, what we have, tonight. First thing, 1/5 again. Now it gives you the same thing, exactly the same thing.
I hope you said he put another
Probably high pass.
this big
And then it gives you a high
architecture.
pass butterwood filter. Yes? Alright, so this one we just use the equation. There's already equation over there. If you're lucky because you already have equation. If not, you need to remember. Right, so you just need to solve that one.
بين. عزة فرحان ها؟ ما نزلت المكافأة؟
نزلت الا والله
So you
فرحان
have
الرجال.
HUV
ما نزل.
equal to 1 over
1 plus 9
plus
over
9 over u square plus v square power as 2n.
Yeah.
Yeah, so you got high pass. So you're given this one with no less than 0.707. And you got u square plus v square is 10. I'm solving that equations.
Yeah.
Confident? So how?
ما جابتين.
So we have
Zero
secant on this.
اي تحت صح.
707 plus 0.707 times 0.9 to the power 2n. So you got 0.9 to the power 2n equal to
يعني كيف
1 minus
2014
0.707 divided by 0.707.
This is ليه 2012
12.
Finished.
it's already written 14 okay
ليه؟ It's much easier this question.
Yeah.
finish this part B finish
Yes. Kind of. So 1 minus
10 marks on this just?
10 marks. Yep. 10 easy marks, right? Compared to Peter Caduce.
yeah it is
4, 1,
easy
4. 4. So you can calculate 2n by take the log of 0.4144 divided by 0.9. Log of 9, so it gives you 8.36.
It will be 9.
No, this is 2n.
Oh.
N is equal to 4.19. Right?
That's what let's fish time.
Yep.
It will be 5, yeah?
So n should be equal to 5. So you go back to this equation and substitute the answer. So what should be the order of the filter? 5.
5 the
Order of the filter. Okay, that's all.
Sounds good.
that's all for today
Yeah.
now we finish
DSP.
quickly okay see ya حبيبي مع السلامة
Plenty of time.